Industry skills, practical knowledge, real-world impact. This is Simple Gyan.
Look at this. More than just a shiny piece of metal, a modern alloy rim is a masterpiece of precision engineering. It has to be light enough to improve your fuel economy and handling, yet strong enough to support your entire car. Today, we go behind the doors of a world-leading wheel facility. The industry standard for alloy wheels is typically an aluminum silicon magnesium alloy. Silicon improves castability, making molten metal flow smoother into complex shapes. For forged products, we utilize the 6000 or 7000 series. Magnesium is the magical strengthening agent that will later double the material's strength through heat treatment. Before melting, engineers conduct finite element analysis. They simulate thousands of load scenarios, cornering G-forces, speed bumps, and pothole impacts. The goal is maximum strength with minimum weight. The final design dictates the entire production path, ensuring safety is baked in from the first pixel. Stage 1 is melting. The raw billets are fed into a massive furnace, heating the alloy to over 700 degrees Celsius. But managing metal quality is where engineering is critical. Molten aluminum is like a sponge for hydrogen. If left inside, this gas will form tiny bubbles, called porosity, as the wheel solidifies, creating weak points. To prevent this, the metal undergoes degassing. An inert gas is bubbled through the melt. Hydrogen atoms cling to the bubbles and are carried to the surface. Every batch is tested using a vacuum density test. This ensures the hydrogen content is within strict engineering limits before the first pour. Most OEM wheels use low-pressure die casting. Unlike gravity casting, LPDC pushes the metal upward, resulting in a much calmer fill and reducing oxide formation. Solidifying under pressure further discourages porosity and creates a denser microstructure, specifically designed for high-stress spoke areas. Some performance wheels undergo flow forming. They take the cast preform, spin it, and use massive rollers to stretch and compress the barrel area. This gives the barrel a wrought-like grain structure, making it much stronger and thinner, bridging the gap between cast and forged performance. For the absolute pinnacle of performance, you need forging. Forging heats a solid cylinder until it's plastic, but still solid, and utilizes monumental force. Immense pressure realigns the metal's internal grain structure, forcing it to follow the contours of the wheel design for maximum durability. Where a cast wheel has a random structure, a forged wheel has a dense, directional grain flow. This makes them exponentially stronger pound for pound. Shaping the wheel is only half the battle. This rough blank needs its strength activated. We do that using the most precisely controlled step: heat treatment. In stage 1, wheels are heated for hours. This dissolves all alloying elements, like magnesium and silicon, evenly throughout the aluminum matrix. Stage 2 is quenching. Wheels are rapidly plunged into water to freeze the elements in that dissolved state, creating a supersaturated solid solution. Finally, artificial aging. Dissolved elements precipitate out, forming particles that block the movement of flaws in the crystal lattice. Strength is doubled. Now for precision machining. CNC lathes handle the turning operations, achieving perfect roundness for the barrel and the exact bead seat geometry. This is vital for maintaining a proper air seal. Every single cut is computer-controlled, ensuring the weight distribution is perfectly symmetric. Multi-axis milling machines then take over, carving the spoke design, center cap hub, and the crucial lug hole pattern with sub-millimeter precision. For forged wheels, machines carve away any non-structural material, creating lightweight designs that are impossible to achieve via standard casting. Protection starts with pre-treatment to clean and chemically bond a corrosion-resistant layer. This is vital for surviving road salt and brake dust. Most modern wheels use durable powder coatings, applied electrostatically and baked in a massive oven to reach maximum hardness. Some receive a diamond cut finish, a surgical, reflective cut across the face that defines the wheel's high-end aesthetic. But we aren't done yet. CMM machines measure critical tolerances, ensuring every wheel perfectly matches the original engineering CAD. X-ray machines scan for internal flaws, while impact tests ensure safety, replicating the validated design safely millions of times over. From a dull chunk of alloy to a masterpiece of strength and style, a synthesis of metallurgy, physics, and robotic precision. Thanks for joining this engineering masterclass. Next time you see a set of alloys, you'll see the science behind the shine. See you at the next factory.